Hello, in this video, we will talk about the rectangular coordinates, which is also known as the rectangular coordinate system or the Cartesian plane. Okay, so there are a few names for this. It's the rectangular coordinate plane, or what we call the Cartesian plane. And we also refer to this as sometimes the x y axis. So just briefly, because I have a video on full recording and the rectangular coordinates plane, but I wanted to present this to show how do we use it with some problems. Yeah. So the rectangular coordinate plane is, or the xy axis, is an horizontal line, which we call the x-axis, and a vertical line, which we call the y-axis. Yeah. And the horizontal number line, right? The horizontal line, which is the x-axis, has numbers. So we have 1, 2, 3, 4. On the left side, we have numbers also, -1, -2, -3, -4. And then we have positive numbers on the vertical line, which is the y-axis. The upper part is positive. Okay. And then we have negative numbers on the bottom. The middle of this is what we call the origin. So the middle is what we call the origin. Okay. And then in each one of these locations where we have what is called quadrants, so they can be broken up into 4 different quadrants. So this is called quadrant 1. Then we have quadrant 2. We have quadrant 3. And then we have quadrant 4. So we have 4 different quadrants on the xy axis or the Cartesian plane. So you will notice that if we redraw this again, if I redraw this, and here we have our y-axis and the x-axis. If we put a point, let's put some numbers in here. If we put a point in the first quadrant, some dot here, let's say, and that dot has some x comma y, and we call that an ordered pair. Okay. So the y, the distance from here to here, from the x-axis, this is our directed y distance. The directed y distance. And the distance this way is the directed x distance. So as we move up vertically, that's the y, and horizontally is the x. So when we have an ordered pair, okay, when we have an ordered pair such as x comma y, okay, this is called an ordered pair. Yeah. And what this does is just give a location on the xy axis. So once again, when we have x, the x, right, the x really is the distance from the y, the x is the distance from the y-axis. Distance from the y-axis. Y, okay, y is the distance from the x-axis. So what does that mean? For example, if we have the point 2, comma 1. So if we have the point 2, comma 1, and I draw the Cartesian plane here, it means that 2, we have 2 units from the y-axis. So if this is the y-axis, and I put some numbers in here, it means I'm going from here this way, 2 units. And the 1 means from the x-axis, from here, I'm going 1 unit. Okay, so maybe I should, let's put that here. I'm going 2 units this way, and 1 unit this way. And if you notice, I am going to fall right here, okay, because that's my 1 unit. So the plotting points is just a matter of moving horizontally and vertically on the XY axis. So I don't plan to spend, or don't plan in this video to show you how to plot points because I have a video on that already. But what I want to talk about is the Pythagorean theorem, the distance formula, and some application as to what we can do. Okay. So let's talk about the Pythagorean theorem. Okay. We want to talk about the distance formula. Okay. We also want to talk about the midpoint formula. Okay. And we'll look at some examples of those formulas and problems relating to them. Okay. So let's start off by looking at Pythagorean theorem. Okay, Pythagorean theorem. And Pythagorean theorem really deals with right triangles. Okay, so for a right triangle, with hypotenuse, length C, and the hypotenuse is the longest side, okay, and sides length A and B, okay, we have a squared plus b squared is equal to c squared. So what it's saying is that if we have a triangle, it has to be a right angle triangle. Yeah. So here is the right angle triangle. And if this is C, and it doesn't matter, this could be A and that could be B, or vice versa, because this sides doesn't matter. What this is telling us is that if we take the two shorter legs, right, the two shorter legs of the triangle, A squared plus B squared, that is equal to C squared. And that's Pythagorean theorem formula. That's Pythagorean theorem formula. We also have the distance formula. Okay, the distance formula. And we can use point xy. Okay, we can use point xy on the Cartesian plane. So as you can imagine, the distance formula is used to find the distance between 2 points. Okay. So if I have a point here, call this point x1, y1, and let's say I have another point here, and let's call that x2, y2. Okay, so the 1 and the 2's just tell me which is the first point, which is the second point, right? So if I have a line connecting those 2 points now, some line connecting those 2 points, we should be able to find the distance. Now, we can sort of use a Pythagorean theorem here to help us, okay? Because I can create a triangle if I want to, a right angle triangle. We can create a right angle triangle, okay? This is some right angle triangle. And what we can do is find the distance D. So if you notice, this point here is the point x1, because here is x1, and here is x2, and here is y2, and here is y1. So this point here is really the point x1 comma y2. Okay, so if we use Pythagorean theorem, which says d, this side here, squared is equal to this side plus this side squared, right? The two shorter legs. So we can use Pythagorean theorem to help us here. Okay, so we can say that d squared is equal to, and since we're speaking of the distance, okay, the distance, this distance here will be x2 minus x1, the absolute value of that, right? And this distance here will be y2 minus y1, the absolute value of it, because we're speaking of distance. So we can say that d squared, okay, is equal to, or I can even redraw that triangle if you want. The triangle that we have there is this triangle here. Just so that it looks less confusing, it is 90 degrees. And we know that this side here is the absolute value of x2 minus x1. This side here, it's the absolute value of y2 minus y1. And this here is d. So by using Pythagorean theorem, if we apply Pythagorean, we have that d squared is equal to the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared. And if we leave d by itself, by taking the square root of both sides, if we take the square root of this side, okay, and remember we're supposed to get plus or minus the square root of this side here, but because we're speaking of distance, okay, distance, we cannot have negative. So what do we have? We have d is equal to the square root of the absolute value of x2 minus x1 squared plus y2 minus y1 squared. Okay. But once again, the distance, this is going to be positive. When we square these things, by squaring, it will be positive. Okay? So we can say that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And this here is how we justify or we prove Pythagorean theorem. We obtain the distance formula. Okay? We obtain the distance formula. So we can use the distance formula to find the distance between 2 points. Always, we can use the distance formula to find the distance between 2 points. Okay, so example, find distance between the points, okay, -2, 1, and 3, 4. Okay. So we know that the formula, the distance formula, d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So what we'll do, let x1 y1, okay, equal to -2, 1. So what we're saying, this here is going to be my x1 and that's going to be my y1. And we can say let x2, y2 be assigned to the value 3, 4. So this means that this is x2, y2. Yeah. Now if we plug those into the distance formula, d is equal to the square root of x2, which we know x2 is 3, minus x1 is -2, okay, plus y2, which is 4, minus y1, which is 1. So we have here that d is equal to the square root of 3 plus 2, because these two negative here becomes positive, squared, plus 4 minus 1 squared. So d is equal to the square root of 5 squared plus 3 squared. Okay. So d is equal to the square root of 25 plus 9. Therefore, d is equal to the square root of 34. And the square root of 34 cannot be simplified, so we leave it as the square root of 34. You can use a calculator, okay? If we use a calculator, we get d is approximately 5.83 if we round it to 2 decimal places, okay? So we can use this to help us find distance. Now, what we want to do is, how do we use this distance formula to confirm things, okay? So suppose I give you this example here. Example. And I want you to show that the points, okay, 2, 1, 4, 0, and 5, 7 are vertices or points, right? Points of a right triangle. Okay. So let's put those points on a graph. And you don't have to graph it. You don't have to graph this, but I just want you to get a visual picture of what's happening. So let's say I have a point here. Then I have a point here. So let's say this is the point 5, 7. Okay. Let's say this is the point 2, 1. And I have some point here, 4, 0. And if I draw a triangle, and we know it's a right triangle, right? So we're assuming it's a right triangle. Okay, so let's call this A, B. Well, let's not call it A, B, and C because I don't want to confuse. Let's call this side S, side T, and side V. Okay, so we can use the distance formula. We can use the distance formula inside S. The 2 points we have there is 2, 1 and 4, 0. 2, 1 and 4, 0. Okay. If we didn't want to call this S, we could call it some distance D1 also, right? Oops. So we could have called this, if we wanted, D1, D2, or we can call this D1, D2, and D3. And then we just, here, let's put them in order. So D1, and for D1, we have 2 points, okay? We have the points 2, 1, and 5, 7. So let's find them in order. So if we use the distance formula, D1 is equal to the square root of 5 minus 2 squared. Okay. 5 minus 2 squared plus 7 minus 1 squared. And if we simplify this, this is going to be, let's do it over here. D1 is equal to the square root of 9 plus 36. So D1 is equal to square root of 45. Okay. So this here is the value of D1. Okay. If I do the same thing now, okay, let's find D2. Okay. So D2 is equal to the square root, and the 2 points for D2, let's now D2 points, okay, D2 points are 2, 1, and 4, 0. 2, 1, and 4, 0. Those are the 2 points that connects the line D2. Okay. So D2 is equal to the square root of 4 minus 2 squared plus 0 minus 1 squared. So D2 is equal to the square root of 2 squared, which is 4 plus minus 1 squared, which is 1. So here we have D2 is equal to the square root of 5. So this is the length of D2. And then we have D3. Here's D3. D3 points, or for D3, we have 5, 7 and 4, 0. So we can say that D3 is the square root of 5 minus 4 squared plus the y2 minus y1, which would be 7 minus 0 squared. So we have D3 is equal to the square root of 1 squared, which is 1. 7 minus 0 is 7, and that becomes 49. So D3 is equal to the square root of 50. So what do we have now? What we have now, we have a triangle, okay? We have a triangle, and we know that these points here, okay, so that's what my triangle had looked like above there. This is the point 2, comma 1. This is the point 4, comma 0. And this is the point 5, comma 7. And we saw that D, let's put it in a different color, D3, D2, yeah, D3 is equal to the square root of 50, right? D1 is the square root of 45, and D2 is the square root of 5. Okay. So notice this here, this is the largest value, right? This is the longest slash largest side, okay? Because the square root of 50 is bigger than the square root of 45 or the square root of 5. So we can now apply Pythagorean theorem, okay? We can now apply Pythagorean theorem, which says that a squared plus b squared is equal to c squared. Well, in this case, in my example, c is the longest side. So this has to be the square root of 50. And a and b can be any one of the two sides. So the square root of 5 plus the square root of 45. Okay. Now remember, we have to square these things. We have to square them. Okay. So this becomes 5 plus 45 is equal to 50. And this shows that 50 is equal to 50. So yes, it is a right triangle. Okay, that means that this point here, okay, is the right angle. Because this is square root of 50, this is the square root of 45, and this is the square root of 5. So here is my right angle. Okay. So we can use these formulas to help us justify things. Okay. Likewise, we have the midpoint formula. The midpoint formula. Midpoint formula. So the midpoint is a point along some line segment, right? So if we have a line, if we have a line segment that join 2 points, we can find the middle, known as the midpoint. Okay. So if we have a point here, x comma y, or let's say x1, y1, and we have another point over there, let's say x2, y2, and somewhere in the middle here, somewhere in the middle is what we call the midpoint. So the midpoint formula, okay, is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. remember, middle is sort of the average, right? Middle is sort of your average. So what we do, we divide by 2 since we're speaking of middle. Middle is your average. Okay. So let's look at an example. Let's write that properly. Let's look at an example. So let's find the midpoint of the line segment joining the points. And let's say the point that I have is -5, -3, and let's say 9, 3. So what we're going to do, we're going to call this x1, y1, and x2, y2. Then we have midpoint. The midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's really the average, right? The average of those numbers. So that gives me -5 plus 9 over 2, and let's make the parentheses longer. And the y1 is -3 plus the y2 is 3 over 2. So this becomes -5 plus 9, okay, which is 4 divided by 2, -3 plus 3 is 0 divided by 2. So the midpoint here is the point 2, comma 0, right? So notice that midpoint, okay, midpoint is a point. Yeah, it is a point. So you will have an x and a y. Whereas distance is a number that represents the length of something. So those are things that we can use the xy coordinate plane or the Cartesian plane as we look at distance and midpoint. And I just wanted to create a short video and show you that, you know, we talk about midpoint and we talk about different scenarios, but it's really stemming from the Cartesian plane. So I hope you can practice some more examples on your own so you become better at this.